This interception is a very interesting interception because quantum security in the year 2026 is going to be one of the major discussion points. And everybody understands that the space is actually the ideal location for the next generational computing, as we are putting a lot of new things in the space, not only satellites, but also compute in the space and in the future data centers. So the space infrastructure is actually real now, and the entry level has become low. Launching costs is being reduced substantially, and the satellites are increasing capabilities exponentially several tiers. So there's a good time to open the discussion. So we have a very prestigious roundtable with experts from the space and quantum technology, and we also have the honor to have with us the Swiss Air Space Military, which they are coming with some very interesting project. So maybe I start like all the roundtables, if you guys can just introduce yourself. And by the way, I'm also happy to have a lady in the roundtable. This is, we always trying to find ladies that represents the crypto space world. So we have Maria Pia with us today. So I give you, the roundtable starts with your presentation.
Thank you, Carlos. So my name is Ludovic Monra. I'm the commander of the new Swiss Space Command. Please, may I have your attention? That's the military guy speaking.
That's the military.
So we created in Switzerland a Space Command responsible to develop new capabilities in space regarding imagery, intelligence gathering, telecommunication, precision navigation, defensive counterspace, and of course we have a high interest to have the best security for our own communication, be it to provide to the troops or for the telemetry and commands.
So just...
hello everyone, my name is Grégoire Ribordy. I'm a physicist by training and the co-founder of a company called ID Quantique, a Swiss company in Geneva, which we founded in 2001 to work on quantum communications and how to ensure long-term data security. Last year, the company was acquired by IonQ. We're now part of IonQ, the quantum computing and quantum platform company. And in terms of space applications, we're involved in two missions. One is a European Union mission called Eagle-1 to deploy a first quantum key distribution satellite. And this is a project run by SES and TESAT. The idea, often when we talk about the quantum risk, quantum computing making cryptography vulnerable, one approach to secure, to fix this, is to use new mathematical problems, post-quantum cryptography. But there's also another approach, which is to use quantum against quantum to do communications at the quantum level. And doing this allows to detect interception of data. This is a technology called quantum key distribution. It can be done in optical fibers and satellite. And maybe in 10 seconds, the last thing we're doing is that we also use quantum to generate high-quality randomness. And randomness is very important in cryptography to produce keys. And we're also involved in a project where we provide, for the next generation of Galileo satellites, we provide the source, this random number generator based on quantum that are space qualified, and we're working with Thales on this.
Thank you very much.
It's quite amazing. My name is Luc Piguet. I'm the CEO of ClearSpace. At ClearSpace, we build a tow truck for space. Essentially, we build the capacity to inspect, to service, extend the life of a satellite, or dispose it in a clean way. Essentially, it's the servicing layer that comes for the space infrastructure that allows to, at the same time, extend the life of assets in space, to make sure that the environment remains operable and clean, but also to protect assets and support sovereign capabilities.
Thank you very much.
I'm Jonathan Certain. I'm the president and CEO of Axiom Space. We're primarily a human spaceflight company. We're building the replacement to the International Space Station. We have an astronaut program, and the next man and first woman to walk on the moon will walk in an Axiom spacesuit. So we're pretty proud of that lineage that we have. But we've also built an in-space compute capability. So the necessary attributes of safe communications for human spaceflight often are also enable secure compute in space. And so we've built this capability. We've got our first two compute payloads operational on some Kepler spacecraft. We can talk about what what orbital data centers actually mean. That phrase is not something that I'm in love with, but I can explain that in a little bit. Looking forward to the panel.
Hi, my name is Maria Pia Akiveke. I'm a token economist technologist and a system strategist architect. I'm part of WISeKey's board member and also former board member of the pension fund administrator industry. I contributor of very well-known financial and crypto media like Diario Financiero in Chile and CoinDesk. I teach about disruptive business models enabled by technology. And I'm super happy, thank you Carlos for this invitation, because the space is opening a new economy where quantum is going to be needed by design.
Thank you very much.
Hi everybody, my name is Mohammed Abulmegd. I'm Vice President at Sandbox AQ, responsible for our cybersecurity business. Sandbox AQ is a quantum AI company that spun out of Google, or out of Alphabet actually, in 2022. It was founded within Alphabet because Sergey Brin wanted to be able to challenge the team with how do you solve really big world problems by leveraging quantum and AI technologies. Spun out in 2022. Eric Schmidt is the chairman of our board. We've raised over $1 billion in capital. And on the cybersecurity side, we help with two things: the safe deployment of AI and with post-quantum cryptography as well. So we work with financial services customers, defense departments. We work with the Department of War in the US, for example, different critical infrastructure companies as well, to help them get ready for post-quantum cryptography. We have a number of cryptographers on staff as well. Actually, 2 of the 5 algorithms recommended by NIST were authored by Sandbox AQ. So really important topic for us, and one that we believe a big amount in, and proud to be partnering with our partners on helping them get there. And thank you for the invitation to the panel.
Sure, thank you, pleasure.
My name is Emile de Renck. I'm the founder and the CEO of Swiss 212. We are a company that builds communication satellites. What we have done is we have made communication satellites smaller, faster to build, and more cost-effective, which essentially lowers the barrier of access to space and allows for more diverse communication missions, but also missions embarking future-proof capabilities, such as the ones we will be discussing today on this panel. Our satellites are being developed in collaboration with the European Space Agency, who are a key partner of ours, and we are currently building 5 satellites for some of the biggest telecommunication operators in space in the world, and very happy to be here today to contribute.
Thank you. My name is Benjamin Guyot. I'm a space lawyer per education, and I'm the CEO and co-founder of Space Talk, a Swiss-based company providing a system for the global space traffic coordination. So we focus on the dialogue between all space operators based in competing space powers. And I thank WISeKey for this invitation.
Thank you very much.
First of all, I would like to say thank you, Carlos and WISeKey team, for this great event. I'm always amazed that Carlos' vision is always 5 to 10 years ahead of everybody. And now we are discussing something which will be implemented probably in some years from now. But it's good to start discussion. My name is Murat Seyit-Nepesev. I am the president of the Greater Caspian Association. We do promotion and development of 18 countries, the region between Romania and Bulgaria and Kazakhstan, Caspian region, Central Asia, South Caucasus, and Black Sea region. And for me, the main interest here is to get new ideas, what could be implemented in our region. And our region is slightly different from Europe, from Switzerland. We don't have so much connectivity in the region. We have a lot of problems. That's why all this is really great. And some of the ideas could be really critically important for our region. Thank you.
Thank you very much, Murat. And he also has one of the largest fleet of boats, containers travel around the world, and they need to be connected by satellite. So thank you for joining us again in Davos. So I'm going to try to, first of all, I am very impressed and at the same time happy to see so much Swiss innovation in space. I think this is, it shows really, I mean, normally all the roundtables that we organize is pretty international. We have a lot of Americans, but this in roundtable, we have a lot of Swiss. And this is interesting because Switzerland being a small country, that vision to go to the space and to use the space as an infrastructure where we can build the Switzerland of the future is actually very encouraging, as this is also obviously boosting the companies that they are being involved in developing that infrastructure. But I think one of the key differentiations is actually the fact that the Swiss Army, it has that vision as well, because otherwise we could stay talking for a long time before we have something concrete happening. So Ludovic, one question for you, and we start with you. What level of sovereign control is required for national quantum communication assets deployed in space? And how does quantum secure space communication change military command, control, and situation awareness?
Well, it's a question which, of course, involves a big answer. First of all, we have to remember that last year, in April of last year, the US Space Force declared war as space as a war-fighting domain. It was the concretization of a movement. That means that the next war will take place in space, and maybe the next war will begin in space. That was the French president said a couple of weeks ago. We have to be sure that it's not the case. Quantum computing is a disruptive factor. We heard that before, AI is disruptive. The more disruption you have, the more chances or risk you have of war, because some people are seeing advantages and a potential benefit to declare war or to act in a warring manner, not declaring war officially. So for us, it's essential to control everything regarding the security of own data. We need the resources and the methods and the tactics to prevent war in space and to keep peace. And for that, you need some military forces. Do the same in space as for the navigation, for the policing of the airspace. We need to police space, and for that you need to have secure communication. You need to be able to prevent somebody to know your intent, your plans, your actions, to be not previsible, and to be able to intervene as fast enough so that you prevent an escalation of the situation. Of course, that would be a good thing if we had some other people, purely Western people here on this panel, because it's a geopolitical situation and the risk of conflict is between the West and the non-West.
Thank you very much. I fully agree with you. I think Switzerland could become maybe an example, a benchmark how to do that without the confrontation aspect, right? The world needs solution. That's the subject of the World Economic Forum this year is dialogue, right? How can we build bridges versus breaking them. So maybe, Ribordy, Grégoire, you founded ID Quantique. That was actually, we were the two first startups in Switzerland, right? WiseKey 27 years ago, something like that. And we were actually at the beginning of the e-voting project in Switzerland when we deployed the first ever binding e-voting project online using a mobile phone and a screen. You have evolved all the way into the full quantum spectrum, but quantum is many things. Maybe can you break for the audience what is really the quantum stack and where you position yourself on that stack, and maybe also about the qubits requirement in order to have something like a threat in this sector.
Yes. Yes, you're right. You know, we both started companies very early. Now, I typically say that I started IDQ in the quantum field probably 15 years too early. So, you know, if I tell you something about timing, don't listen to me or take it with a pinch of salt. Yeah, so quantum, you know, quantum is the science that was developed in the first 30 years of last century. And there was a first quantum revolution. This is all the IT technology that we have today comes from quantum, you know, semiconductors, lasers. But it's quantum when you use a lot of quantum objects together. And we're now at the beginning or the end of the beginning of a second quantum revolution where you use individual quantum objects to do things that are not possible with classical technologies. And there are essentially three areas. One is quantum computing, using qubits, so encoding information on quantum objects, and that allows you to make calculation much faster, super useful in optimization, AI, drug discovery. but also it brings a threat, the so-called Shor algorithm, which was invented in 1994 by Peter Shor, and that allows to factor large integers and break the cryptography that we use until now, more or less. And that's a challenge. One way to address this risk is post-quantum cryptography, but also using a second area of quantum communications, using quantum object to send information. And so if you send photons, particles of light, in an optical fiber, typically in classical communication, you send millions of photons per bit. And so it's possible to intercept these pulses by just taking a few percent of the light, you get 100% of the information. Now, if you send one photon at a time, it's a quantum object, and in quantum, if you measure something, you modify it. So that allows to detect perturbation. A second application of quantum communication is to connect quantum computers. Because just like with classical computers, when you build a computer at some point, it becomes economically better, instead of making a bigger one, to just make two and network them. And the third pillar of quantum technologies is sensing. Of course, if you use very fragile objects, these are good to measure physical properties. So you can use quantum technologies to measure the magnetic field, gravitational field, application in positioning. And so these are the three fields of the second quantum revolution. And I would say, now is really the time. And I think the next 5 years are going to be extremely interesting. We heard in the very first panel this morning by a gentleman from IBM that they're planning to have a quantum computer that can break RSA in 2029. 2029 is tomorrow. If you look at the security infrastructure that we use and that we need to upgrade, it is tomorrow. And so that's an important thing to note is that we, as all organizations, must have a quantum strategy to get ready.
And this is actually, thank you very much, and this is actually a full or a strategy on CLSQ to provide a PQC capability before that threat arrives, right? Because in the United States now you have the CNSA 2.0 that basically says that all the critical infrastructure of the United States needs to be PQC enabled before the year 2027 in order to avoid a potential disaster in 2029-30. So yeah, absolutely a great momentum. But back to the space sector, Luc Piguet, question is, what minimum operational rule, collision avoidance, debris mitigation, end of life must be embedded in quantum satellite constellation from day one? What is your views on that?
So yeah, I think that at the end, a satellite integrating quantum computing or capabilities is a satellite, fundamentally. When we look at it, obviously we're not experts in quantum. What we do is servicing. So our concern is, how do we build a space infrastructure of tomorrow that is capable of doing more with less, ideally, and capable actually to be resilient, to be sustainable, to be able to operate in a way that is not possible today, to provide also agility and mobility as we move forward. So I think the regulation the policies and regulation that are being put in place right now to make sure, first of all, that we don't produce more space debris are what's needed, concretely. But then beyond that, any spacecraft as we move forward have to be more and more thought through in a way that it can be serviced. Essentially, the thinking behind it is that today we have servicing on the road, we have servicing in shipping, in the shipping industry, we have servicing for aviation. We don't have servicing for space. The question is what happens once you're able to do that. The other element is that there's a lot of element of operation that you can integrate out of the gates. For example, have to change hardware, replace hardware, being able to upgrade the technologies as they move forward on the spacecraft, on the capacity in orbit. And those require a very different way to look at the space infrastructure and the way we operate it. So to be able to actually implement most of the changes we want to do in the future, we need an infrastructure that is able to operate differently than the one we have today, which essentially is built as a consumable that is single use. But really think through, okay, fine, how do we make an infrastructure that can be maintained, upgraded, improved, can be moved? How do we provide mobility in orbit in a way that we cannot do until now? So that's really the concern we have.
Thank you very much. It's actually an amazing company, They're solving one problem that not many people are trying to solve, right? That's I go to Jonathan from Axiom Space. So why is space emerging as the most trusted layer for global quantum key distribution compared to terrestrial fiber networks? On that area also, it's important to know that some quantum companies actually are acquiring a space company, like the IonQ acquisition of Capella, and also the Signal company. We also have YSAT attached to Seal SQ. So this is actually an interesting market emerging now on combination of both. So yeah, sorry, the question is, why space is emerging as the most trusted layer for global quantum key distribution compared to terrestrial fiber networks?
I don't know that I would make the comparison orbital versus terrestrial. I think orbital offers a different component of resiliency that's not enabled on the ground, and that additional or alternative resiliency is the combination of a kind of a slew of emerging technologies that have all emerged over the course of the last several years. In-space solid-state compute, radiation-tolerant, low-swap devices really allow you to store substantial amounts of data on individual spacecraft. Combine that with optical communication terminals, which can take advantage of wave division multiplexing and maybe in one day polarization division multiplexing to enable post-quantum encryption. That technology is now well established. Starlink, OneWeb, Amazon Leo are all using these optical communication capabilities to improve the overall bandwidth, the backplane, if you will, of the spacecraft network. 400 gigabits per second is something that's achievable these days. So sufficient compute is the last technology necessary to have a sufficient data center capability, if you will, and the combination of all of those things allow for secure communications in space. That also allows sovereign nations access to that secure communication without necessarily having to build the overall infrastructure that larger sovereign nations can do on their own. And so the combination of all of those different technologies, I think, is what enables that post-quantum encryption deployment in space. I think the last part of this, which is kind of Axiom focused, really is as humanity expands to access additional resources, it's necessary for secure communications. And so those investments, whether those are for in-space servicing, in-space secure communications, or permanent human presence in settlements in space, all of those things require these technologies. And it's just, as AI is accelerating applications for advanced compute, it's also enabling ancillary, maybe spin-off technologies, spin-off commercial enterprises like a human establishment in space. And so it's really an exciting time to see all these things emerge at the same time. It's also a scary time because of the capabilities that it enables. So I'm going to keep my head down in color.
I fully agree. So before we go to you, Marie-Pierre, I would like to involve Mohamed on that discussion. So Mohamed, how should organizations prioritize migration to post-quantum cryptography in space and hybrid infrastructure? Maybe also, because you are a sandbox, some information about the combination of AI and quantum, how that relates. This is part of your core technology.
Yeah, of course. I think maybe I'll answer the second question first. So when we look to apply quantum technologies and AI together to solve real problems. And most of the time when most people kind of mention quantum, they think about quantum computers. But there's all sorts of other technologies that are quantum-based. Quantum sensing is one of them. Our CEO just gave a talk actually and explained kind of this concept at another one of the houses where sensors today, an example of a sensor would be like a thermometer, where you have kind of old technology that can sense the temperature in the room and then be able to change it based off of some old technology that takes place. Quantum sensors can do something very similar, being able to sense kind of the changes on the quantum level. We leverage those types of technologies to solve different use cases. So an example is with navigation and GPS. GPS is one of the most spoofed technologies out there. I think the president of the EU Commission just experienced an attack or an incident at the end of last year where GPS spoof happened, it was blocked, the plane lost its navigation and had to be able to land on short notice. What we are trying to do at Sandbox, an example of where we're applying quantum technology, is apply quantum sensors to planes, be able to understand where the plane is relative to the magnetic field of the Earth that's been imprinted into the crust of the Earth, same types of magnetic fields that we play around with our compass and other things as well, and then be able to navigate the plane relative to where it is in the Earth. So there we leverage quantum sensors to understand where the plane is. We leverage our AI to be able to take that signal, filter out the noise, and then be able to confidently guide the plane. So we're really looking at different ways to be able to apply AI and quantum technologies to solve some of these really interesting problems. When it comes to cryptography...
So in that would be around physical AI, right?
That would be physical AI, yeah. Yeah, when it comes to cryptography, and we span across the board in terms of the number of different use cases we solve for, really at the core is we want to take quantum technologies and AI and solve a broad range of use cases. So that navigation one is one that that is one example. And it's not just airplanes. I mean, we're working with submarine manufacturers to be able to navigate submarines as well. I don't think we're working with anybody in any spacecraft or any kind of space use cases, but I can definitely see that there's maybe a potential for us to be able to do that and help out with that use case as well. When it comes to cryptography, I mean, getting ready for when PQC day or for when Q day comes is going to be absolutely critical. The date that was mentioned of 2029 is when IBM thinks a quantum computer is going to be able to break RSA is going to come out, is absolutely coming. It's going to be within this decade. And all of our digital infrastructure depends on encryption, and that's what's going to be broken and what's going to be at risk. So being able to upgrade to post-quantum cryptography is going to be absolutely critical for us to be able to do. And it's not even a 2029 problem, it's a today problem. What we're seeing in the conversations we have with different organizations is they're getting attacked today, and we're seeing what we call harvest now and decrypt later attacks, where adversaries are finding weak points in your infrastructure, they're breaking in, they're stealing critical data, which are the crown jewels. These are the mission critical data that's absolutely important for every organization, and they're waiting for when quantum computers are going to be able to break it. So a lot of the organizations we work with don't just see the urgency of getting ready for when Q day comes out, they see the urgency today that they need to address.
Thank you very much, very comprehensive. Maria Pia, who should control and access the space-based quantum computing resources, state alliances or global public-private platform? Which is your view on that?
Layered. Layered. We need states to set the red lines. We need alliances to create standards and avoid the fragmentation and include cooperation for responses, to keep the system resilient. And at the same time, we need public and private platform partnerships to scale this. But, before dipping on this, I would like to wrap up something that is very, very interesting, that it has to do that space capabilities have been really, really like leapfrogging. So now it's moving from just connectivity to giving other capabilities that are surveillance and of key infrastructure for mining, for energy, and at the same time, this is going to be the backbone of a new financial asset. This is going to be a space-based financial assets that is already starting. There's some insurances that they just activated with the surveillance done from space. So that's why we need this layered strategy. Also, space is very interesting because at least it's a blank space. We can use all the technologies that are converging, using DLTs and whatever is needed, AI, etc., to avoid what is happening on Earth. That is, that we are not cooperating, and that we are giving the wrong incentives also from the financial markets.
It's actually unfair. We are talking and they are eating, huh?
Yes.
Okay, so back, Emil, how do new RF and antenna technology enable scalable and cost-effective quantum communication satellites?
Well, I think having strong communication capabilities to and from space and between assets in space is of course the backbone that you need, and that's going to exchange the information that you will want to encrypt. So we're really very active at Swiss212 on that layer of the infrastructure. We have innovated a lot in what's called payload technologies for radio frequency communications using novel technologies like 3D printing to essentially package the amount of data throughput that you would traditionally find in much larger satellites into much smaller satellites, which is very helpful to just disaggregate the infrastructure and to the point previously made, also create more layers to the infrastructure that can add resiliency to a global network. And then if you combine this with, for instance, quantum key distribution techniques, you can create a very safe and reliable network to communicate with.
And what is the regulatory aspect of it in order to establish those connections? Do you, maybe just...
So from a radio frequency perspective, of course, you needed an ITU filing to emit radio frequencies out of orbit. So this is a very well-oiled system that works since decades. But when it comes to optical, you don't. So when you work in the optical domain, you actually have very little regulatory limitations to establishing inter-satellite optical links, or even distributing quantum keys through optical means from orbit to ground or between assets in orbit.
Because yesterday I gave a keynote at The Economist, and I was with an expert, American expert, and they were telling us that they have a constellation of 200 satellites with optical capability, that they are able to map the Earth at 200 meters, 300 meters, so they are able now with AI to detect if one country, for instance, is organizing troops in the border in another country. So all that intelligence now is being collected from the space, analyzed with AI, and then used to create predictability analysis and what-if analysis scenarios. It's actually amazing how it is becoming the Google of indexing the material thing, the physical thing. Let's go a bit on the secure satellite communication aspect with Benjamin. How does quantum safe satellite communication differs operational from traditional encrypted SATCOM?
Difficult to say. It's not really my topic on this, but it's more communication and secure communication will greatly help more space traffic in general, because we face a difficult situation today where we have no unique system for the global space traffic coordination, in particular no dialogue between operators based in the US and in China. So building a unique system implies secured satellites data, and quantum computing will greatly help this, in particular for space traffic on low Earth orbit, but also for the deep space exploration missions. When you send space objects to Jupiter, for instance, you need to use the force of the various planets on the road. And it's only by having a very strong calculation capacity through this quantum computing technologies that you will be able to improve and to improve the missions, and in particular also for the low Earth traffic assessment. So we all wait for this, but there is also a question of timing, because satellites do not all have the latest technology on board. For some space objects, satellites developed by Starlink, for instance, they build satellites in about a few months, 1 year, so they can really implement very latest technology. But for other space objects, you need sometimes 20 years to develop them, such as the James Webb Space Telescope, meaning that you don't really have the latest technology inside. So it means that when you're going to have quantum technology for space connections, you will not be able to connect all existing space objects, and you're going to have old car on the road still working while not being able to communicate with others. So there will be really maybe 20 or 30 years to have a full implementation of this kind of technology in space.
I agree. So Murat, what signals should investors look for the identify valuable quantum space business model? And maybe also because you are so much involved in with the United Nations on the trust issues. Well, how can we bring trust in this space? What will be the key elements for it?
Yes, I think one of the options is still to use United Nations. Because today in the world there's only one trusted platform. And of course there are a lot of problems with the budget crisis and so on. And under the umbrella, this could be done, the trust. And another idea is, like was already mentioned by my friend Nicolas, that to create kind of a council of experts who are really well-known and trusted professionals who can write recommendations which could be later implemented through the international organizations. And of course, in the United Nations, there is ITU, for example, also International Telecommunication Union. They could be very much effective in building this trust. Otherwise, if you will give this to the particular countries, particular governments, they will pull on their side all the time, then there will conflict in interest, and you will never get the proper trust. On the other side, to give it to the business community also, then there will be no trust from the government side. That's, I think, the only solution here, international organizations.
And do you think, because the space is so broad, so big, and it's going to be so expandable, do they need to have a specialized agency for that? Because ITU covers telecommunication, AI, it's too much on their plate. What will be your view? Is that a space? You need to create an international space agency in Geneva?
Knowing how United Nations agencies are working, I think better to create something new. Because to reform ITU, for example, is a mission practically impossible. It will take ages, and then we will have in 5 years the new ideas on new sessions, and they will not be able to follow up. That's why, yes, something like International Space Agency in Geneva, for example, will be the great idea. Yeah.
Because the space is going to become vertical, geopolitical, and sovereign, right? That's the way it goes, and that maybe just connect to the question to Ludovic. How should defense institution assess the real world timeline on quantum threat versus today's cyber risk? Is any can you sleep at night?
Well, yes. I can sleep at night. But frankly, of course, there is a huge amount of risk of things going from bad to worse, especially in space. The reason why I try to sleep good at night is to put things forward and to develop solutions, especially in Switzerland, sovereign solutions. That's the reason why we have been developing our partnership with WISeKey and especially WISeSat in the last 3 years to have a solution when you have a sovereign capability to encrypt our own telecommunication. When we know from end to end that the data will be secure, at least for a certain amount of time. Because the whole thing regarding this quantum computing, it's a matter of time. You will decrypt messages, but the time that the message will be decrypted with PQC is enough to allow some tactical actions and to have some real-time reactions to the data you get from space. So the real solution is to have this layer of security being put on over all other parts of military operations to ensure your sovereignty and, of course, the integrity of your decisions.
Absolutely, and maybe because space is expensive, and I can tell you, I launched some satellites, and it costs a lot of money to launch satellites. What is the business model? Anybody of you want to discuss about the business model on the space? How do we make money out of space? Is by providing satellite as a service? Is by developing, launching capability? Europe is very unserved in what concerns launchers. So, we have the legacy ones, but the new ones are struggling for finding money. I just came from India. I visit ISRO and Skyroot. And Skyroot is having a lot of financial problems. ISRO is not performing as good as SpaceX. So investors get a bit scared, to enter into this sector because it's still very in infancy. Anybody of you guys have views on that? Yeah.
Maybe I will start because I'm somehow related to the business and investor, also business on the ground. And as I told, I'm from the Caspian region, and the Caspian region is, especially the Central Asian part of it, the least covered by the usual mobile network. And we did the research together with Vaisky. Some years ago, we saw that practically 80% of the territory is not covered. And then the only solution is the space, the satellite communication. And we were discussing the project, how to organize track and trace system for containers, not only for containers, it could be for everything, for trucks. And then the only option is to go via space. And here there is a very clear monetization model. And could be really attractive for the investors, because if you don't have traceability, you don't have bank financing, you don't have insurance, or you overpay this. And then, of course, clients, they don't know where their cargo is, where is the container, they're losing their contracts, and so on and so on. That's why it's clearly the business case. And I think here, satellite communication, it's really critical. And here, for the investors, it should be very good, very attractive, and it's very profitable also, because sky is the limit. You can charge quite a significant amount.
And we have Starlink IPO of 15, what is it? 1.5 trillion, right? That's the offering. So that's going to activate the appetite of investors this year. By the way, I am doing an IPO, YSAT, in end of March, 250 million markup initial. So that means that there is opportunity, but we are still struggling to have we understand how to make money, sending the satellite, renting the satellite, but what is the recurrent revenue model that you can activate for satellites? You want to say?
Well, so at least for human spaceflight, first of all, there are many sovereign nations that want to train astronauts, and that builds an anchor tendency. So while that's still an expensive enterprise, the cadence of launches is driving down the overall cost, and the standardization of lots of different components in the supply chain are driving down the expense associated with procuring and assembling and launching and operating spacecraft. SWISTA-12 is using innovation to drive down the costs of content in space. So it's still expensive to get things into space and operate them, but cadence is certainly making an improvement there. Standardization is certainly making an improvement there. And I think one of the more important attributes of that is setting up a security system in space, especially militaries providing the necessary protections for assets in space, are driving down some of the expense for doing so. And this is how humanity has evolved as it's expanded across the globe, right? First, militaries go off, determine what resources are available, they instantiate a presence, investors come along, they put up investments, oftentimes early days, very speculative investments. They get large returns on those investments. They set up settlements. They expand. They gain resource. They move on. We're in the early days of that. I akin it to, 1993, sitting in your living room. You've got a modem. It's 1,200 baud. It took forever to launch a website. But, 15 years later, there's a $1 trillion enterprise with websites. 15 years after that, there's another $1 trillion of communications, application layers, et cetera. So we're early days in space, but the necessary infrastructure to enable that growth of the economy, that's what's happening now. It is speculative in many of the types of investments that are being made, but without those investments, the large returns from things like SpaceX and others wouldn't be there, because there'd be no economy, because that safety wouldn't be assured, et cetera. So, 10 years from now, I think we'll be talking about the applications that we are developing in space, not the infrastructure that we're developing in space.
And do you think, yeah, Ludovic, but maybe just on the same line, do you think the role of Europe will catch up against the, I will call the pragmatic view of the United States? Because the difference here, when I go to the United States, you have huge government support and funding for this type of activities. Many companies we know, Palantir, even SpaceX has started by being funded by government contracts. We are not able to do that in Europe. So how can we compete? Is that something that we need to teach the government about the consequences of not? Because otherwise the industry will be monopolized in one territory. Any views on that?
Well, I wouldn't say that Europe isn't competing. I would say that Europe isn't competing at scale. And Europe is not competing at scale, in Jonathan's opinion, because there's a difference between risk aversion and risk tolerance. or risk acceptance and risk avoidance. And in Europe, there's a lot of risk avoidance. And in the United States, especially with investors, there's a lot of willingness to accept some amount of risk. And the consequence of that is more available capital. And so maybe one of the things to consider in Europe is a little bit higher tolerance for risk for those investments, and the consequences might be increases in returns on dividends. But again, I think Swiss to 12 is a great example, just to use that on this panel, of a combination of investment both from ESA and Switzerland and innovation that is leading to a direct competitive capability to things that that other industries, other competitors globally they're being competitive with. So I don't think it's a lack of competitiveness. I would say it's a lack of competitiveness scale because of this risk avoidance versus risk tolerance.
Ludovic, you want to say something?
Just to answer your question before, I think that it will be possible to make real money in space with the conditions Jonathan just mentioned, but when it will be faster, safer, and cheaper to produce things in space. And probably with the advent of Starship, with the development of new technologies regarding computing, the day we have data centers in space which are cheaper to operate, cheaper to build and to operate than on the Earth, it will be another revolution. Then it will be way more interesting to do things in space. Right now we are talking about off Earth. It will come. Many things won't be done anymore on the Earth.
And it's more energy sustainable as well, because space has not the same problem of energy, right?
Space as a service, but not just communication, not just internet, not just data. Also, enabling other capabilities on satellites and nano-satellites, such as imagery of what is happening on Earth. Also, solar energy in space is being proved. And this is the kind of also services that can be added on top. For instance, maybe not all the solar energy in space will be for providing energy for a house or a neighborhood, but it can, for instance, more than 2,000 nano-satellites could support their access of solar energy for computing, data, and that kind of things are services that are also going to be provided. These are the space-backed financial assets, they speak, and that they're going to be as a services because there's a barrier of entrance, of course, that still it's going to prevail for a long time. And especially if, before ending, especially if you provide end-to-end solutions, like, for instance, WISeKey is creating its ecosystem that includes identity of devices on Earth, and at the same time, providing trust intersection between autonomous machine to machine. That is also a service that finally will be also, it's linked with the space capabilities. So, and you can sell them separately depending on the client needs.
So one question, Mohammed, maybe on just one question for Mohammed. The 29 Q day, as IBM said, satellites are going to be exposed. So what happened with the satellite infrastructure that we have in 29 about everything with concerns about the harvest and decrypt process? Maybe some views there, please.
Yeah, I think it's the same problems that we see for all of our infrastructure here on Earth, or terrestrial infrastructure, are the same problems you're going to see for the infrastructure that we have up in space as well. Encryption is at the heart of being able to secure the data that we have in transit, the data that we have at rest as well. And I think those use cases, those paradigms, kind of exist today with what we have with our infrastructure in space as well. And it becomes really, really critical, potentially even more critical actually, that you prioritize the infrastructure that you have in space because of the types of applications that space infrastructure really supports. Like when we work with organizations, they're usually they're usually taken aback by how much they actually have to upgrade. So one of the key things we talk to them about is prioritization. Prioritize your most critical assets first that you need to be able to upgrade to be PQC ready, to be ready for when Q-Day comes out, or just to have better encryption in general. And I think in terms of prioritization, space assets should be right up at the top of the list. So I think a similar type of approach, similar type of kind of risk exists, and because of the nature of the use cases that satellites and other space infrastructure really supports, from military to critical communications, et cetera, those should absolutely be right up at the top of the list of what we upgrade first today in terms of the encryption algorithms they utilize and beyond as well.
Thank you very much. So, any other comment? Otherwise, we'll like to close the panel. Yeah, you have something, yeah, please.
Yeah, one last comment regarding the European capacity to go in space. We have great industry in Europe on space activities. We have great minds also. It's true that we lack money, investments, but what does not count much, or what can be already done right now, is defining a strategy for the development in space. We miss this in Europe. We should now agree that we have to transfer a big part of our economy to space, and we should have a plan in the 10, 20, 30 years to come on how, on which part of our economy will be in space for the future, because it's clear that we can solve many issues we have in Europe on accessibility, on energy, on development in general. But we don't have this because maybe we are still too shy, because it looks like science fiction to imagine that we will live in space. But either we go to space and we progress and we develop, or we just die here on Earth. Huh? So it's almost a black and white choice.
Maybe, Ludovic, the battlefield in space, there is common sense that the next war is going to be in space. Do you see that coming? And what will be the way that you can protect your assets in space? I am asking now the military to...
What a question. Thank you very much, Carlos. Rulers in space. Well, there are a lot of science fiction been written on it. Of course, I don't know. But right now there is a race. There is a new race into space. And the US is winning the race. And it's due mainly to SpaceX and many things being brought with SpaceX. And I don't see a change in the next 5 to 10 years regarding this race. Because the capabilities, the technologies being brought together lead to this situation, and the reaction has been too slow to correct this in a short term. So there will be an opportunity to do new things in space, maybe on the moon, maybe on Mars, and that could be maybe a new ruler. I hope it will be still something democratic.
Thank you very much. So if you don't further questions, I don't know if the panel wants to ask any questions. Otherwise, we're going to close the panel and I let the panelists to enjoy the lunch. Any questions? We have a few minutes. Yeah, please.
Yes, I understand that IBM is the most advanced in quantum in terms of bits. But isn't it supposed there are other companies that are advanced and other things that can help the actual building of quantum computing?
Yes, yeah. So there is a race currently to build what people call a fault-tolerant quantum computer. So a quantum computer that is not vulnerable to errors in the calculations. And to do that, you have different ways to build the qubits, these elementary parts that you use to calculate. People talk about qubit modalities. IBM is pursuing one, which is the superconducting qubits. It's one approach. There are 3 or 4 approaches. Our company, IonQ, we work with ions, so elementary ions that are trapped. The advantage with this approach is that ions are made by nature, they're atoms, they're all the same. And so you don't have to tune ions, you get exactly identical qubits, and so that makes a lot of things easier. I think so, in general, we believe at IonQ that we have the best approach to scale this. And one of the big questions will be also how energy efficient will be a quantum computer. Because a lot of these computers require cryogenics, and if you need to cool something, to a big machine to a very low temperature, and we're talking about less than a Kelvin, so very, very low temperature, that takes a lot of energy. So, I would say the race is still on. but there are a few different companies that are trying to achieve this.
Yeah, just something quick. Isn't it supposed that in terms of, isn't it supposed that in terms of infrastructure, the Finnish, in terms of infrastructure, the Finnish are the ones that are very advanced in cryotechnology.
Exactly.
So they are in Europe, so because we are talking about how we don't join forces to accelerate not only in this, but in everything, in AI, in the economy, in geopolitics.
Yeah.
So this will be an advantage because they have that.
That's a good point. You know, there's this company, Blue Force, from Finland, which is very good in cryogenics. That's the pick and shovels of quantum computing, you know, the tools that you need to put together. And then there's the full stack quantum computer. And to be honest, I'm a bit skeptical. I think the US will win the race for the full stack quantum computer because somehow there's not enough money going into European players, and Europe, to some extent, is afraid of picking winners. You know, they kind of spread support kind of equally over too many competitors. In the US, there's more money, and there's also selective money, and that's why Europe is going to lose the race, but potentially still find attractive niche to provide certain parts of a quantum computer.
Actually, we are consolidating that part because we are buying Quantum Company, which has announced the acquisition for $200 million of Kubli. Kubli has a different model of IonQ. It's not at the ion level. They generate the qubits based on semiconductor technologies, which is a bit the European model. It is maybe longer, but it's more stable in terms of we know when and how we can predict the qubits to be created. And CLSQ now is in competition IonQ. So we are friends, but at the same time we are competitors, and we are a Swiss solution, which brings another dimension of that, which is a trust model, right? So it's going to be an interesting fight. Anyway, we have been fighting for nearly 25 years. 27. But anyway, I think in any case the world needs both. I don't think it's going to be one or another. They are, you know, they are very big players. Like in Kubli is ST Microelectronics behind. Is a major player, so we are obviously very ambitious on what are our destination, and that's why we are also investing in space. So I think this was an amazing. You have one more question? Okay, maybe one question more, and then I want to wrap up. Maybe if you don't mind. Yeah. Okay.
Thank you very much. My name is Milan Pimprikar from Montreal, Canada. You know, I heard a lot about the creating this collaborative structure, mitigating the risk, finding the, you know, the issue of funding, the defense and so on. How about, you know, something which is a quantum platform in space, like a condominium in space, where you can have encryption in space for the partner to share the data with collaborative, like a platform where European, Canadian, North American, all we have. As I said, it's you can have an encryption based on your contribution. So you could have, let's say, a satellite. Not everyone needs to have a complete satellite. You can have the proportion as a fractional ownership model, I would say, you know, where you can have countries sharing together, especially when it's looking at this quantum, you know, in terms of the safety, the security issues, and so on. Is this something that can be developed, something as a collaboration platform in space with the quantum, you know, encryption?
From my humble opinion, that's amazing vision, and it will be great if we can achieve it. But we didn't achieve that with the internet, despite that we have been trying for so many years. I think we need a new human mindset to make that possible. I think it should be, you know, because the space is universal and it's global, and the space doesn't have frontiers. You know, when you're in space, and all the astronauts when they go to the space, they really have the same opinion. Wow, the Earth is only one, and there's no border. I cannot see the difference between countries. It's a philosophical question. I don't know if we are yet wise enough as humans to reach that, but obviously that should be our objective, and I think that we should all work towards that achievement, yeah, for sure. Okay, so thank you very much. Just maybe if you can join me to give a hand to the panel for the amazing participation. And I just would like apologize for the number of panelists. I know this is a bit unusual. Normally you have 1/3 of it. We have 30 panelists in 3 roundtables, so this is amazing. But the objective was to get the opinion of everybody. We didn't want just one expert to provide an opinion. We want to decentralize knowledge and wisdom. And this was achieved, I think, by the 3 roundtables, and they are very convergent. And this was the subject, is the age of convergence, where all those talents will work together towards developing a better society where humans, we can prevail and become relevant as we have been from the last 200,000 years. So thank you very much. I'm sure next year we'll have a similar event. There will be maybe more robots, less speakers. Anyway, our commitment is to continue developing the Davos agenda and make sure that Davos also has our opinion, and it's not only a political opinion, it's also the opinion of the user. Thank you very much, everybody, for your time and presence, and thank you to the panel.